appreciate you guys taking time out, and thank you and welcome to our ICM Controls webinar on ICM450 and 530 series. And these are great products and really starting to take off as like hot button items in our industry. A lot of issues with power and power interruptions, power anomalies these days, and this is these items are very popular right now. A lot of chatter about them out there, so we're going to teach you everything you need to know about these. You know, from a sales standpoint, also a bit of technical, like as deep into the technical as you need to get probably. And so we'll start off with the phase monitors. First, though, let's talk about why you need a line monitor or a surge protection device. Power plants generate electricity, and then after that, they will typically have a step-up transformer so that that voltage can travel long distances. So we're talking, you know, 400,000 volts. Those are those big, high, you know, metal power poles, the big that are spread out across the landscape. That's carrying that high voltage to the substations. So substations will then break down the power. So substations step down the power to industrial facilities, for example, operating on 600 volts. Then there are substations that'll step it down to 460 volts, and that goes to commercial buildings, the type of stuff that we typically deal with in the HVAC industry. You'll see, you know, commercial three-phase 460 volt power. It's more efficient to operate equipment at 460 volt if you can, as opposed to 208, 230. So a lot of times they try to go with that 460 volt if it's available. And so we sell a lot of line monitors and surge protection devices around that 460 volt voltage. But they're also we also have devices for 230 volts. So the 450s cover everything, and then there are separate surge devices for those different voltages. But any disruption in this chain, and you can think there's a million things that could happen in the chain that could cause power interruptions, spikes, surges, dips on the line, and that can damage expensive equipment. So we're going to look at three-phase line voltage monitors, and you guys are all probably familiar with our ICM450. Great product, ICM450 line monitors. They provide a line of protection from voltage swings and other power anomalies that can damage equipment. The settings are adjustable, so you set your parameters for over/under voltage, and then as long as the incoming power is within that range, it will allow the equipment to start. Otherwise, it interrupts that contact or coil circuit to take line voltage power offline. And then it continuously monitors the line on incoming voltage with true RMS, which is an improvement that was made on these recently. True RMS voltage is just like hooking up a meter to the to the equipment. So accurate, doesn't have to be calibrated. It's all factory calibrated and is highly accurate. So during power disruptions or if voltage is outside the selected range, contact or coil circuit.
All right, I'll get it. Hold on. I got it. Hold on.
What do you got? And then, so here's some of the features. ICM450 and 450A plus. There's only a couple of feature differences with the plus, but it's necessary in some cases. But they both have a nice backlit display, lighted backlit display, simultaneous three-phase true RMS voltage monitoring on both models, all factory calibrated. All three legs are displayed on the monitor at the same time, so you can see the actual voltage for each leg. It's got 50 fault memory, fault monitoring, high voltage, low voltage, unbalanced phase loss, and phase reversal, which can be devastating to equipment, especially unbalanced phase loss, phase reversal can take stuff out in a hurry. Real-time clock, date and stamped time on the 450A plus. And the thing that's nice about that is if there's an anomaly happening at, let's say it's happening at the same time every day, it might be peak time, peak power time during the day, and they might be seeing the same failure over and over. This gives you a little bit of leverage with the power company. They're not always as cooperative and easy to work with, but they may have a bad transformer, or they may have some issue that's causing this power anomaly that can take out equipment, and they don't want to take responsibility for that. So to have that logged on the monitor, now you can actually go to them and say, hey, look, this is exactly what's going on. And so it's cheap insurance, but it's also gives you a little leverage with power companies. Very simple configuration, fully adjustable variables that are very intuitive and easy to adjust. And then on the 450A Plus, it does also have Modbus RS485 communication capability, which is really good because then you can tap into building management systems and things like that. So that's been a nice feature add as well. LED indicators tell you what's going on. And we changed the connection terminals to these quick connect terminals, like a spade terminal. So you can put an insulated spade terminal in there. A couple of different things can happen. First of all, you can reach in there with the screw type terminals and get bit, by electricity if you're not careful. But you can also short some things out if you're not careful with those open exposed terminals. So this is a safety feature and just problem solver, kind of a headache solver. English or Spanish menu options. You can choose either option. It's built into the device, and that's been a very good feature too. We sell a lot of these things down to Latin America and all over. So some of the specifications: wide voltage range 190 to 600, frequency of 50 or 60 hertz, load side monitoring, which is very nice. I'll explain that a little bit. Control voltage of 18 to 240 VAC, so it covers pretty much everything out there. And single pulse double throw relay, and lot of nice electrical, wide range of electrical features in there. Surface mount or optional DIN rail mounting, and then those 1/4 inch spade terminals for easy connection. So the way this thing wires up, it's so super simple. So you got L1, L2, and L3, and basically you're just taking those straight to L1, L2, L3 on the contactor, using jumper off of there. And then it's got load side monitoring also. Now the device can function on just the line side. You don't have to do load side monitoring, but it's a great option. We at ICM Controls actually had a situation at our old building, previous original building in Cicero, New York, and where a spider had, built a little nest inside one of the contactor legs. And, when they powered up AC after several months, it was taken out one of the legs. So on the load side monitoring is great because you might be fine over here, but when that contactor pulls in, are you getting the right voltage coming off of the load side of the contactor? So we monitor that, and if it's outside the range, then we'll break this coil circuit and drop that out. And one more thing, if you have questions along the way, please type those in. We're going to try and answer questions along the way. If there are slides coming up on it, I'll let you know that. But otherwise, we like to kind of answer the questions so that we can get that out of your head and make better use of the entire presentation. And Jesse, if you would call those out to me as we go, we can probably answer everything that you guys have. Another condition that, thank you. Another condition that can be very devastating is unbalanced voltage. And this little chart here shows you. So this is a normal voltage, all three legs. This is unbalanced condition. And what can happen is even with a 2% voltage imbalance, it can increase the motor winding temperature by 8%. And that's pretty significant. And that's just with a 2% imbalance. Go all the way up to 5%, you're 50% increase to the temperature of the motor windings. As you can expect, that could cause damage very quickly. Take out compressors, motors, everything else. So very important to have a device like this to monitor that and drop it out if that condition exists. And you'll know what's going on. It'll show you the imbalance condition. Go in, make that correction, and you're off and running again. This thing is very easy to install. We're going to show you a quick video. One of our reps, Matt Valent, former contractor in the field, very knowledgeable guy, does us the courtesy of recording some of these videos for us so that we can see how these things are installed. Very, very simple. And we'll get that started here. Tell me if you can hear it okay.
Keith, I'm not hearing it.
Not hearing it? Okay, not hearing the video. So let me go back to my share and click this on. Let me go here. Let's see if this is better.
Hi, my name is Matt. I'm with United Components.
You're good.
I'm the local rep for ICM
Can I do
Controls
it?
here in Syracuse. Today we're
Yep.
at the Upstate Systems Factory approved training lab. Today we're going to be installing a couple of ICM's new and improved controls to protect three-phase equipment. This is their new and improved ICM450A line phase monitor. We're also going to be installing a three-phase surge protector, ICM530. Some of the upgrades over the previous model are it is now a true RMS sensing product. It has 50 fault codes memory. They put quarter-inch spade terminals on the unit now instead of screw terminals. It's got a backlit display so you can easily see it. Includes English and Spanish. And lastly, nice thin profile. So I'm going to go ahead now and install this on this 10-ton rooftop. All we need is a clear space to put it. I have to put some pigtails on it, a couple screws. Keep in mind safety first, so you want to make sure you turn the disconnect off to the power source for your unit. You want to find a big enough area to set this in comfortable. Get your hands out of the way. Easy to work on, easy to see. The unit does come with self-tapping screws to make it easier to go through the sheet metal. Now our unit is mounted, we can go ahead and wire it. Connect our wires to L1, L2, L3 terminal here in the unit. This is your incoming. We're on the back side of that. So we went ahead and connected your L1, L2, L3 terminals to the wire that runs down to our incoming terminal there. Just want to secure your wires, get them out of the way. Nice little zip tie. So after we got our control wired, we can go ahead and turn the power on. So first we're going to read the voltage. This is actually the sensing voltage, so it says 210 volts. So we're going to go through the setup. The first one is you're telling the unit what voltage you do have.
Oh.
So we're going to change that to what it said on the previous screen, 210 volts. Delay on break is just your timer, how long it locks out. Leave that at 15 seconds. Delay on fault, 15 seconds. Next is your over voltage. This is where, just as the same as the previous model, this is fully programmable and customizable. I'm gonna get that. We're just taking this one down to 10% so we can see how, just show you how programmable it is. Under voltage, same idea. You can adjust the percentage of under voltage is allowed before the unit protects itself. Next is your phase unbalance. So that's the 10% as it's monitoring the difference between the three different lines as to what's an allowable, out of range. So we'll get that to about 5%. The control mode, this is selectable to on or off. If you select it to on, these two terminals become active. This is where you can select English or Spanish for the menu. And that's it. We've finished setting up our ICM450A. One of the additional benefits of this product is it has the ability to monitor the load side of a contactor. You want to protect a motor, you want to protect a compressor, this will do it. So all we have left to do is connect our wires from the load side protection of our 450A to the load side of one of our contactors. Number one, you're going to want to make sure that your power is off. And you just run your leads up to T1, T2, and T3. At this point, if your phasing is off from your load, the unit will tell you. So last thing we have to do is take the power off of your transformer, connect it to the common side of the 450A, take a jumper wire from the normally open terminal, and connect it back to the 24 volts on the transformer. So now our unit is completely protected against phase loss, over and under voltage, any line voltage issues we might have from the power grid. So we're going to go ahead next and install the three-phase surge protector for the 208/230 power. So we all protect our TVs and computers at home. This is the same idea, just to help protect this expensive piece of equipment. So let's get started. So we just want to carefully feed our wires through that hole. Now the box comes with a gasket for the outside and a retaining nut for the inside. So when you're done, you just want to make sure it's nice and tight. So now that we got our surge protector mount on the outside of our equipment, we can go ahead and wire it. I just want to say a few things about the 530 series. This one is the 208/230 volt three-phase. They have a 480 volt three-phase, 600 volt three-phase, and also a 208/230 delta highlight. So for the ICM530, it needs a ground or neutral, but in this case, there's no room for where the neutral/ground is, so it's just grounded to the unit, so we just screwed it to the chassis. Phase does not matter for this surge protector. So now that we're wired up, we're going to go ahead and turn the power back on. Now that we got our power back on, you want to make sure everything turns back on. We got our phase monitor on, and we have the green light indicating that this is ready to protect your equipment. So now our unit is completely protected against power surges and voltage anomalies. You can check out our full line of single phase and three-phase power protection products at ICMcontrols.com.
Okay, so easy installation on both products. The reason that we married those together, if you're installing a three-phase line monitor, they do a great job at preventing the equipment from starting if the voltage is any of those conditions we looked at before. If the voltage is outside that range that you set, or if those other power anomalies occur. The thing is, a surge is a different kind of an animal. A surge is a very rapid event, and a line monitor won't always see that. It happens too quickly and can actually damage the line monitor itself. It can damage the equipment. Still, surges are, a line monitor is not a surge protector. A surge protector is not a line monitor. So the good thing about the line monitor is it does protect you from over and under voltage. Brownouts are equally dangerous to equipment, but the spikes, line monitor can't really do much about that. So the surge protection device is very, very critical, and we're going to spend a little bit of time talking about that here going forward. But nice installation video there on how to install those. And then we do have some competitors out there, as always, right? Mars, Motor Saver, Copeland, Time Mark, and so on. Thing about it is ICM manufacturers in Syracuse, New York, high quality product at the most competitive prices. So I would put our protection and quality of build up against anything out there. It's a device that's going to last. It's going to offer you protection, and you know, the price points we typically are competitive with anything that's out there. A few of the design upgrades, as I said, we've got the Modbus 485 communication port on the 450A plus. That's a picture of a 450A, but it's on the plus model. and the real-time clock also for the time and date stamp on the 450A plus. So if you're in an area that historically has some bad problems with power, or something that you're trying to diagnose, I would say, go with that 450A plus. It's not that much more money, and it offers a few more really nice features. Both have the English-Spanish menu. The spade terminals, I told you, are safer and less likely, to have shorting or any kind of problems going on inside there. And the backlit display is very nice. So again, competitive advantages. We provide complete product line for protecting compressors, motors, other electronically operated devices against phase loss, over under line voltage issues caused by any of those conditions that can happen with the power grid. You can have lightning strikes, you can have problems at the distribution, anywhere in that distribution network. You can have a blown transformer. You can have, a car accident crashing into a power pole, something like that. Dips in voltage, even problems at the service at the house, the lug, behind the main, your main panel at home, main outdoor box at home. All these conditions can occur, and something happening way upstream, from the power plant or transmission lines or commercial facilities, whatever problems there can come downstream and cause you problems. In commercial facilities, even equipment, some equipment may require really high amp draw, and when that equipment shuts off, can cause surges on the line. So there's a ton of different conditions that can occur, and we're seeing a lot more of it nowadays too. The government wants to put more pressure on the power grid to support electric cars and electric everything, and we're just not designed for that. We aren't up to the challenge yet. So surge protection devices, line monitors become even more important. These are best sellers. We're recognized as a leading manufacturer of these types of controls, and these are some of our best selling items. What we've done is we've redesigned a lot of controls, re-engineered, redesigned controls around some of the more modern type of components, internal components, the best stuff that we can get, but that's the stuff that's most readily available in the world markets. What we saw with some of our things like thermostats and things like that are using older style chips. Those manufacturers don't want to make those chips anymore. They want to sell you the new stuff. So we're adopting the new stuff, and it makes our products more readily available, and trying to get ahead of some of these crazy supply chain issues that we've seen for the last couple of years. But ICM is a great company. If you ever get a chance, take a look at some of our videos. There's videos of our production facility in operation. It's fascinating, impressive, and right here in the good old US of A. So three-phase surge protection devices. We have single-phase surge protection devices. We have single-phase line monitors as well. Right now, we're focused on three-phase stuff for the more, like commercial type applications, where our commercial mechanical contractors do majority of their work. So three-phase surge protection devices, again, why do you need a surge protection device? Because there are so many conditions that can cause those voltage anomalies that can damage equipment. So, lightning strikes, bad transformers, and it creates this very quick transient spike that it's so fast, like I say, that oftentimes the line monitor won't even see it. If you see numbers on the screen of the line monitor going away or going wonky, it's time to install a surge protection device. There are surge protection devices on big commercial city power poles and things like that. That's what these devices are on these transformers. These are surge protection devices, and they'll absorb lightning strikes and other things. So basically they're MOVs, or metal oxide varistors, a variable resistor. And these are large. These are very large, but the MOV discs inside here, and you see there's a series of them. Like in this, they have 4 large MOVs in there. And the MOV disc is a semiconductor that's sensitive to voltage. So at normal voltages, the MOV disc is just an insulator and it's not conductive. But at higher voltages caused by lightning or something, it becomes a conductor. What happens is As the temperature goes up, the resistance of the MOV goes down. So it just draws that excess voltage into the MOV. And that's how it, pulls those surges away and deals with them internally. We use in electronics manufacturing something much smaller. We use a TMOV, or a thermally protected metal oxide variable resistor. What's inside that are these zinc oxide grains, these little metal grains inside the device. So the way it's wired in, it's zero resistance. It's just on the line, voltage is passing through it until there's a condition. So when that spike occurs, the resistance lowers in here and it draws that surge in. And these metal oxide grains absorb that heat and then dissipate it off. If the surge is small, the metal oxide grains may absorb the spike and dissipate the heat with no degradation to the TMOV. It might be fine, a small enough surge. If the surges, as they get larger and larger, it may melt and fuse a couple of these metal oxide grains in there. And so that's how it degrades. It's continuously taking those hits. It can take multiple hits up to the specifications of the device, but it's taking those hits, dissipating the excess voltage as heat. And then as those metal grains, get burned up, it has less and less capacity to offer the surge protection. So very clever little devices. And we already use these. We all use them. Your surge protection strips, your power strips at home that protect your TVs, computers, gaming systems, music equipment, anything, your expensive equipment, you've got them on power strips to protect them. And so why on earth wouldn't people want to protect the most expensive equipment in their home or in a business? It's just foolish, really. So the surge protection devices, what you'll see inside those are usually these small little MOVs. So for electronics manufacturing, they're using a lot smaller components. Now, those are degrading over time. If they're getting hit with surges, these things can be burnt up and not offering any protection at all in your power strip. You should change them every once in a while. They typically don't have an LED on there or anything to tell you that it's not offering protection anymore. Ours do. You're going to see little boxes like this, much more robust, much higher capacity to take those surges, TMOV. So it's a thermally protected metal oxide variable resistor, as opposed to these little simple devices in the power strips and stuff. So in the 530 series, as was mentioned in the video, there's 4 basic models. They'll do a Delta or Y configuration. You're probably going to see Y configuration more often in our industry. They're NEMA 4 watertight plastic enclosure, welded plastic, fully waterproof, and suitable for indoor or outdoor applications. There's an indicator light to tell you if the device is still offering protection, and very easy to connect. These are a type 1 or a type 2 device. Type 1 is approved for whole home or whole panel protection. A type 2 is not. So a type 1 for whole house panel will protect every breaker on the panel, but it has to be installed in a certain way. It has to be installed where incoming power comes in before it goes to the bus bars. So we've got a little short video to show you on that too. It's just hooking up one of these to a 3-phase panel. It's as a type 1. What Matt was doing in the video, he was doing that as a type 2. A type 1 can always be a type 2, but a type 2 is only approved for a single breaker or device, piece of equipment. It can go on the piece of equipment like he did, or on a disconnect outside, something like that. So there's 4 models, and what they are, the 530 is 3-phase 28230 Delta or Y, 28230, and then the 531 is 460 or 480 3-phase. Those are the most common ones that we're going to see here. The 532 600 volt, we're not going to see that a ton here in the US, but in Canada, when they do 3-phase, they're 585. So if you're up in the Great White North, then the 532 is probably a good fit for you. 533 is a delta high leg, kind of an odd condition. It's sort of an anomaly, but it is out there. And you see there's a red wire on this. So on the others, the wiring doesn't matter. You know, you got 3 blacks, L1, L2, L3, doesn't matter. And then the neutral wire. On this one, you see you've got that red wire for that high leg. And then basic wiring on this, hook any of the 3 black wires to L1, 2, L3, doesn't matter. Feeding the main breaker. This is for a type 1 installation. And then hook the white wire to the neutral bus. This configuration protects everything on the panel because it's at the start where power comes in, and it's going to absorb that surge and then send good power down below. The thing is, your equipment won't go offline. So if our surge burns out, if it finally, the TMOVs are all used up in there and the light goes out, your equipment's not going to go offline. It's going to continue to work. You just don't have protection. So time to change the device. But if you're just doing it for a single breaker, then you hook any of the 3 black wires to L1, L2, L3, feeding that desired breaker, hook the white wire to the neutral bus, and now it's only protecting that breaker or whatever equipment is on that particular breaker. So we've got another video. This one's about 2 minutes. It's awesome. And it's out there on our ICM Controls website. But do you have sound? Oh, you know what? You might not have sound, huh? Because I think I have to do this.
We do.
You do?
Keith,
Okay,
it was
good.
playing with sound. Yep.
Okay, good. Here we go.
Hello, Jesse from ICM Controls. We're here at a commercial construction site and we're going to be installing an ICM530 series surge protective device on this sub panel in the building. We're going to have the help of Art from AHR Mechanical to help us with that installation. So without further ado, he's going to take us through the process.
Shut off power to the appropriate disconnect. Verify all power is off with a voltage meter before proceeding with the installation. Drill a 3/4 inch hole if a knockout is not available. Feed wires through the hole and tighten the locking nut on the nipple. Connect the white wire coming from the surge protective device to the neutral terminal in the distribution panel. Connect the 3 black wires from the surge protective device in parallel with the 3 incoming line wire terminals in the distribution panel. The black wires are not specific to L1, L2, or L3 and can be installed in any order. Turn on the power to verify the installation was successful and the LED indicator is illuminated green.
That concludes this fairly easy installation here of the ICM530 surge protective device. Just remember that if the LED light is illuminated, then you are fully protected, and if it is off, then the device will need replacing. If you have any questions or concerns, you can reach out to ICM Controls technical support or visit the website at icmcontrols.com.
Very nice, short and sweet. And you see in the presentation again. We're back on the slides.
Yep, you're in good shape.
Oh, okay, thank you. So yeah, great video. I like short and sweet, and it was great because, you know, they showed you good close-ups of right where you're hooking up to main power, and that's protecting the whole panel, all 3 bus bars on there. Same thing with whole home for residential. You need to get it where incoming power is coming into that main breaker. Only way to do that is, you know, to turn it off at the meter outside, and that's going to require a licensed electrician. So single breaker protection, a type 2 installation, any HVAC guy can do that. But the type 1, you do need to be a licensed electrician to get it into that main power. So some HVAC guys have license to do that, and it's a good way to go. So competitive advantages, you know, we've got the highest ratings in our class. The capacity 150,000 short circuit, 150,000 volt short circuit, and 200,000 amp rating, on par with anything out there, any device out there. And you know, some of the people like in the electrical industry, Eaton and so on, that are known, you know, for their devices, we're on par with any of that. Our quality and our capacity for protection. Delta and Y configuration, a lot of those competitive models, they're selling you a different product. You have to buy, you know, you have to carry a ton of different SKUs and everything. Ours is kind of all in one, and that's really great. And the fact that it's a type 1 or type 2, and that NEMA 4, suitable for indoor or outdoor. So it's a really, really great device. And these are actual pictures of our production facility. We make everything right there in-house. It's just really an awesome place. Competitor pricing analysis, you can see some of these brands that we're talking about are in the, you know, $350 to $550 range, $450 to $550, $1,000 and up, $2,000. You know, very high priced stuff compared to ours, which run in that range of, you know, $120 to $170. Best in class ratings, best value by far, and on par with the quality of any devices that you see here. We always encourage. Lately, a lot of us have been stocking more. We stock more component parts inventory nowadays to stay ahead of supply chain issues. Distributors are kind of having to do the same. So now is the time. Like I say, we've got plenty of inventory on hand to serve your needs. The media library on the website. Our website is chock full of every piece of information you could possibly need. Please go out to the ICM Controls and check out our media library there. Logos, product images, cross-references, the videos, all the stuff that we've been talking about. Online catalogs, suggested stock list by region, the hot items that ICM selling in those regions. PIM data makes it very easy to set up new products and things. And so we really appreciate your time this morning, taking time to learn about these products, and let's go look at some questions. What do we have over here?
Also, people can unmute themselves if they want to verbally ask any questions.
Okay. So I see an answer. Eric Wood typed an answer out there.
Yeah, Eric and Mike have been helping out answering some of the questions as we go along. But to begin, in reference to the 450 line voltage monitor, it's, someone asked, "Can you pull the event log from the 450?" And yes, you can pull off the event log of the last 25 volts.
Actually, I think it might be 50, but on the 450, 50 volt memory, but 25 at least. And then Harry, this was one of the guests that was asking a question, going back and forth with Eric Wood, one of our engineers. But it says, can the 530 be installed using a 3-pole breaker off the bus? And yes, it can. That's how you would do kind of a type 2 installation to offer the whole panel protection the correct way. It needs to go right where incoming power is, like the video we saw. That's the best way to offer whole panel protection. Otherwise, you know, you're already downstream, and the other breakers that are on that panel, like sometimes you may mount one here and there's an adjacent breaker. Is it really protecting everything on there? So.
But yes, you can. It is type 1 and type 2.
And type 2, yes. No alarm on them. There is the light, so you'd have to be able to look at the indicator light. And do you see any other questions there?
There was, what is ICM doing to combat long lead times? And you have touched on some of those things, but I don't know if you want to reinforce.
Yeah, the long lead times, it just depends on the product. And like I said, certain thermostats and things that we're using older chips that those manufacturers don't want to make anymore. We definitely, can run into some issues there. The problem is then they tell you, well, we don't have those, but you can buy them from a broker. So then you go to a broker and they want to charge you, I mean, sometimes the increase is not even feasible. We can't raise the price on the product that much to build those and still make any money. We're all businesses and we all still need to make money, have a right to make money, but it's making it really difficult with some of the older style components. So by re-engineering our products around the newer component parts that are more readily available in the world market, we're able to get out in front of that, offer you a better product that has more features and then is more readily available. So we always encourage everyone to, if you aren't adopting our newer versions of products, please do, because you'll be more satisfied, your customers will be more satisfied, and you'll get them quicker. So hopefully that answers the question there.
One other thought there is that we are producing more universal products to try to reduce some SKUs and combine some SKUs. And also investing in newer and better equipment and investing in people as well.
Yeah. All our products are UL listed. Let's see.
Somebody asked if we have a recorded copy of this, and yes, we will. There will be some quick editing of the beginning and end and any technical difficulties, but those will be up on that media library that Keith just showed on the website. And just a quick example of how to get to that: you go to our website, and right there in the main navigation is a link called Resources. Once you click that, you're in the media library, and these webinars will all be listed typically the following day after they're recorded under the video section.
Awesome. Okay. Thank you for that. And then Christopher Baxter asked a question: are these approved for use in panels ICM450A? I do not know the answer to that myself. Does anybody in our crew have an answer for that?
Eric answered it up a little bit, Keith.
Oh, okay.
Yeah, they're standalone devices approved by UL. They fit within UL 60730, which is the new standard per Eric. So
okay, perfect. So that does it for the questions, unless anybody has anything else. Thank you guys very much again for taking time out. We value your time, and hopefully this was informative, and we'll help you guys sell a few more ICM450 A's, 450A pluses, and the 530 series three-phase surge protectors. Give us a call if you have any questions at all. Don't hesitate to contact us, and please take a look at the ICM website for just all the great content that's out there. So with that, we will wrap it up. Yeah, thank you guys very much. Everybody have a good day.